Hi, my name's Andrew Massey. I'm a Senior Test Engineer at BSI Loughborough. I'm the Senior Test Engineer of the Mechanical Controls team. We test all components coming from the gas distribution plants right up to your cooker and boiler in your house. A lot of these products require a high temperature resistance test to make sure that during a fire, if it should happen, that it will not contribute to the fire. Typical products that are tested like this are ball valves, cooker hoses and general fittings around the house. Here I have a ball valve which has not been tested for fire resistance, and here is one that has been through the fire resistance test. Basically, inside of a ball valve you have non-metallic components. During the fire these will melt and then create leaks throughout the pipework. What we are trying to make sure is that the flow does not increase too much. To do this, we have an electric furnace that we had custom built, which can produce temperatures up to 900 degrees. This has been built in conjunction with ISO 834, which basically means that the furnace can actually heat up to 650 degrees in 8 minutes. Inside here, I have a sample set up ready to go for a furnace test. Here we have a typical ball valve that you would find in your property. We have it connected to a gas line coming in, which we will feed using nitrogen at temperatures, at pressures of 1 bar at this time. The sample, if need be, will be supported during the heat so that the sample can't bend and create unforeseen leaks. The samples are actually installed using a graphite paste which does not melt away during the furnace test. Although the furnace works to 834, we can actually run this at any temperature rate up to 900 degrees as specified directly by the client. As I mentioned, that the ball valve will be pressurized during this test. There are some products that aren't pressurized during the test but are pressurized after the test. The pressure and the flow rate are actually monitored by an engineer throughout the entirety of the test. The engineer will actually reduce or increase the pressure depending on what actually is happening with the sample itself, and is monitored by our pressure gauge. The flow rates are monitored by a rotameter, and again this will be handwritten by the engineer who's running the test. So to sum up, the furnace can actually produce temperatures of 900 degrees centigrade and can increase at a rate of 650 degrees within 8 minutes. Primary testing is to EN 1775 using the ISO 834 temperature curve, but we can actually program this to meet any demands of a client.